Okay, hello teacher. Today our team is going to talking about nuclear fusion, one of the most promising energy technology for the future. And first, I will explain what nuclear fusion is, how they work, and how they generate energy. What is nuclear fusion? Nuclear fusion is the process of joining two hydrogen atoms to form a heavy atom. The process releases a amount of energy is the same natural process that power the sun and other stars. How does it generate energy? When hydrogen atoms join target, they release a lot of heat. The heat can be converted into electricity for home and business and industry. In my opinion, nuclear fusion is one of the best energy technology because it is clean and powerful, has the potential to provide energy for millions of people in the future.
Well, thank you, Ariel, for your exposition. As you beautifully explained, nuclear fusion is no longer science fiction. It is a reality in the making. Today, humanity is putting its resources into unprecedented historic projects. The most notable global effort is ITER in France, the world's largest magnetic confinement plasma physics experiment, where 35 nations are collaborating to prove we can achieve net energy gain. Now let's talk about the advantages and the importance of nuclear fusion. First, nuclear fusion is virtually inexhaustible. The primary fuel is derived from seawater and lithium. Just 1 gram of this fuel can generate the same amount of energy as 11 tons of coal. Secondly, it's absolutely clean, and it releases zero greenhouse gases and leaves behind no long-living radioactive waste. And third is inherently safe. There is zero risk of meltdowns like Chernobyl or Fukushima. Now, next, let's talk about the counter argument. Why fusion outperforms hydrogen? Well, Team 2 is here to champion hydrogen energy, but let's look at the hard physics. Hydrogen is not a primary energy source, it is an energy carrier. To get usable hydrogen, you have to spend massive amounts of energy upfront just to separate it from water or gas. Now, how can this energy can generate a real world impact? Well, to put this into everyday perspective, a single fusion plant would occupy the same footprint as a conventional power station, but it could provide uninterrupted 24/7 clean energy, regardless of whether the sun is shining or the wind is blowing. To end, with our final reflection, the climate crisis cannot be solved with temporary bandages or technologies that require more energy to produce than they actually yield. The future of our planet demands that we aim higher. Nuclear fusion is quite literally bottling the power of the Star Trek here on Earth. It is the definitive, clean, and infinite energy humanity needs for the next millennium. Thank you.
My team, now Team 2, is going to be talking about hydrogen energy and refuting some of the arguments in favor of nuclear fusion. I want to tackle first the arguments against the nuclear fusion before getting started on why hydrogen energy is better. The first argument I want to talk about is how they say that nuclear fusion will produce practically unlimited amount of energy. And this argument refers exclusively to future possibility and not a current reality. Nuclear fusion seeks to reproduce on Earth the reactions that occur inside stars such as the Sun. To achieve this, scientists must create a plasma at extremely high temperatures, keep it stable, and keep it confined, and ensure that the reactions produce enough energy continuously. The problem is that there is still no commercial nuclear fusion power plant regularly supplying electricity to a city, an industry, or even an electrical grid. Therefore, when it is claimed that fusion will provide practically unlimited energy, our response should be that it could, but it doesn't. The second argument is how fusion has already proven that it can produce more energy than it consumes, and that statement requires an important clarification. In fusion experiments, energy gain can be calculated in different ways. For example, many researchers may compare the energy used directly to the heat of the plasma with the thermal energy produced by the fusion reactions. However, this does not necessarily include all the electricity consumed by the facility, such as the magnetic systems, the cooling, the pumps, the lasers, the control systems, and the fuel processing. It kind of produced approximately 500 megawatts of fusion power from 50 megawatts introduced specifically to heat the plasma. This is described as plasma gain to factor of the 10. Therefore, demonstrating energy gain inside the plasma is not the same as operating a profitable and self-sufficient commercial power plant. And the last argument I want to talk about is how fusion fuel is readily abundant. This statement is partially correct, but mostly incomplete. One of the most studied reactions for future fusion reactors uses two hydrogen isotopes, deuterium and tritium. Deuterium can be extracted from water and is relatively abundant, but tritium, however, is scarce, radioactive, and must be handled carefully. For fusion power plants to operate continuously, it would need to produce enough tritium inside the reactor to replace the amount it consumes. This process would require special system known as breathing blankets, generally involving lithium. If you could pass to the next slide, please. So, talking about hydrogen energy in specific, I want to talk about what hydrogen energy is. It refers to the use of hydrogen as an energy carrier. Hydrogen can store energy, it can transport it, and it can release it later for electricity, heat, transportation, and industrial processes. Unlike nuclear fusion, hydrogen technology is already being used today, although their environmental impact depends on how the hydrogen is produced. Hydrogen is also the lightest chemical element, and it normally exists as H2. Since it is usually found combined with other elements, such as oxygen in water or carbon in natural gas, it must be separated before it can be used. For this reason alone, hydrogen is not considered a primary energy source, but an energy carrier that stores energy obtained from sources such as solar, wind, or natural gas. Hydrogen can be produced by electrolysis, a process that uses electricity to separate water into hydrogen and oxygen. The hydrogen can then be stored and transported for later use. In a fuel cell, hydrogen reacts with oxygen through the electrochemical processes that generates electricity, heat, and water without producing the direct carbon dioxide emissions at the point of use.
Now that my teammate has explained what hydrogen energy is and how it works, I'd like to talk about its main application and why this technology is becoming so important. Hydrogen can be used to power cars, buses, trucks, trains, and even ships through fuel cells. It is also used in industries such as steel manufacturing, fertilizer production, and chemical processing. In addition, hydrogen can store renewable energy for long periods, helping provide electricity when solar panels or wind turbines are not producing enough power. Can you show the next slide, please? Okay. And why is hydrogen energy so important? Because it helps reduce greenhouse gas emissions, supports the transmission to cleaner energy, and offers solution in sectors where batteries are not always practical, especially in countries that have heavy transportation and large industries. It also improves energy security to a lot of countries because it can produce hydrogen using their own renewable sources instead of relying on fossil fuels. For these reasons, we believe that hydrogen is not simply another alternative energy source. It is technology that can work together with renewables to create a cleaner and more sustainable future. Thank you.
Now, I'd like to explain why my team believes hydrogen energy is more important than nuclear fusion. First, I'd like to clarify that we are not saying that nuclear fusion is a bad technology. In fact, it has incredible potential. However, the biggest difference is that hydrogen energy is already becoming a reality, while nuclear fusion is still in the experimental stage and will probably take many more years before it can be used on a large scale. Hydrogen can help us reduce carbon emissions today. It can store renewable energy, power factories, fuel trucks, ships, and even airplanes. It is one of the few clean energy options for industries that are very difficult to electrify. For example, countries like Japan, Germany, and South Korea are already investing heavily in hydrogen infrastructure. Hydrogen powered buses and trains are already operating in several cities, and many companies are using green hydrogen to reduce industrial pollution. Also, the other team argues that nuclear fusion could provide unlimited clean energy in the future. We agree that that is an exciting possibility. However, the future does not solve today's problem. Climate change is happening now, and we need solutions that can be implemented now. Hydrogen is already helping us move toward cleaner transportation and industry, while fusion is still being developed. Another argument that people say is that fusion could eventually be cheaper and more efficient. That may happen one day, but today's energy transition cannot wait for a technology that is not yet commercially available. Hydrogen allows us to make progress while scientists continue improving fusion. To conclude, we believe hydrogen energy is more important because it is practical, available, and already making a difference. It supports renewable energy, reduces emissions, and helps industry become more sustainable. Thank you for listening. We believe the best technology is not the one with the greatest future potential, but the one that can improve our lives today.